Right, BGP path. Border Gateway Protocol is important for the path selection that you can achieve um, very easily than any other routing protocol. The other routing protocols do support tuning of path, but the way that BGP supports is more flexible than any other routing protocol. So we need a protocol which will understand our policy in path selection. So using attribute only we do this. Learning attribute in BGP is what the actual learning. Knowing how to enable BGP, knowing what is eBGP, IBGP, that is not the big learning. Learning about attribute is what really matters in BGP. We got 0 to 13 attribute. We'll see that attribute in a sequence. You see here it is, sorry, 0 to 11 attributes, not that 11. This is 0th attribute. I consider this as a 0th attribute for top. You need to have a valid next stop. That is the very important attribute. Next stop is one of the attributes, and it should be a valid reachable next stop. And if you got multiple paths with valid next stop, then it goes to the first attribute called wait. And then if there will be a tie in wait, then only it goes to local preference. If there is tie in local preference only, then it will go to origin. If there is tie in that, then it goes to the shortest AS path. If there is tie in that, then it will go to the lowest origin code. Lowest origin code. Origin code means what? How it is originated, how it is injected. Is it redistributed or advertised? Advertised using network command will have I. Redistributed will have question mark. Which one is preferred? Lower is preferred. Which one is lower? I is lower than question mark. I is lower than question mark. Then what is this E? E was once upon no. E was once upon a time a protocol. Like BGP, we had EGP. That was an old protocol. That's not eBGP. That's EGP. There was a protocol earlier. Now that protocol is no more. So you will never see E. You will see I or question mark. Now if there is tie in this, only then it will go to MAD. If there is tie in MAD, only then it will go to eBGP path preferring over IBGP. What if both are IBGP? Then it will go to the closest IBGP neighbor. What if both are equal? It will check the oldest EGP path, EBGP path. What if that is also same time both the paths gave, both the neighbor gave the same path? Then it prefers the neighbor whose router ID is lower. Definitely here will be a tie break. Router ID cannot be same for two neighbor. In case by mistake, if someone might have done the same router ID, then it prefers the one with the lowest neighbor address. See, this is the sequence. You need to know the sequence by heart. You should remember the order, the sequence always. Only then you can be a successful BGP engineer. That sequence matters. I know these are all no fine. You know attributes, but do you know in sequence? Yes, you should know in sequence. So I'll give it. You got multiple paths, and I have tuned the local preference, but okay, I tell you. Now, see, I got router 1 here, router 2, router 3, and I got another We call it as ISP, and I have two connections. Okay, so we are getting some routes from the cloud. Let's say 1.1.2.1. I'm learning it from router 4, router 5, and this is autonomous system 10, autonomous system 11, autonomous system 12, 22, and go on. It goes on. There are many autonomous systems. I have just drawn 4 of them. You see, I have set high local preference here, meaning I told this router that this is the best exit for anyone to reach this. This is the best exit. But it is not going that way. What may be the reason? When you set local preference on one router, let's say 200, the default local preference is 100. The default local preference is, forget about weight. Local preference is another attribute. I have set local preference 200. The default is 100. Everywhere it is 100. By configuring local preference 200 here, what I'm expecting is I want everyone, including router 3, to go this path to reach 111. But it is not going. What may be the reason? It is still going via router 3. See, immediately your mind should go to the sequence that you learned. I am talking about local preference. Wait, I am helping you. No. Wait. I'll give you time. Uh, First of all, you need to see the sequence. Where does local preference come? As you are saying, trying to say, the 0th position is valid next hop. The first one is high weight, highest weight. The second one is highest local preference. The third one is local origin. The fourth one is shortest AS path. Fifth one is origin code. I is preferred over E is preferred over question mark. And then sixth one is MED, multi-exit discriminator. Lower is preferred. For MED, low is preferred. And then number 7 is EBGP is preferred over IBGP. EBGP is preferred over IBGP. Number 8, if both are IBGP, then closest IGP neighbor. If both are EBGP, the oldest EBGP route, oldest external route given by EBGP, oldest BGP route. If both are same time learned, nothing is old, both are same timing, no one is old or new, then it is going to see the highest, lowest route ready. And if there is a tie in this very rare case, this itself will be a tiebreaker. And the 11th is lower neighbor IP address. Neighbor's router IP address. Yeah. So this is the sequence. So whenever you troubleshoot BGP, if you have this in your mind, when I am saying troubleshooting, I'm not talking about the mistakes that we do in configuration. No. This type of troubleshooting, meaning I'm supposed to go via router 2. I need to troubleshoot so that my traffic will go via router 3. So my mind should now check the sequence. Why the path is not via router 3? Why it is always going via router 2? I don't know. What about the first 0th point? Did you check that one first? See, you remember yesterday we learned that this router will advertise this router's address as the next stop. So router 1 will learn about 1.1.1.1 with the next stop address router 4. Can router 1 reach router 4? No, sir. Router 4 is a different autonomous. How router 1 knows about this subnet here? இந்த வயர்ல இருக்கிற நெட்வொர்க்கை பத்தி ரவுட்டர் 1க்கு எப்படி தெரியும்? நீங்க என்ன OSPF ரன் பண்றீங்க? So there are two ways in solving this. Either you should advertise this network in OSPF that you may be running inside, or you should say what? Next hop self. Do you remember, sir? So maybe in this router, next hop self is not given. That may be the reason. So you should start from very beginning. Should not leave that. That is why, even though it is not listed in the attribute, I consider it as a 0th attribute. See, I put 0. This is a mandatory one which we should check. 0th attribute. Okay. First, you check the next hop. Is the next hop reachable? Okay, fine. Let us say in both the router we have said next hop self, and for router 1, both the next hops are reachable. But even then, the traffic is going via router 3. Now tell me what may be the reason. Next hop problem is fixed. Okay. I appreciate. See, you started thinking, only when there is a tie-in next hop, it will come to wait. Only when there is a tie-in wait, it will come to local preference. So if the wait is a tie break, it won't come to local preference. Even if you set 200, it is of no use. Why? Maybe in R1, you might have given high weightage towards R3. So because this is a tie break, it will never come to local preference. What 200? Even if you set 2000, it is of no use. Why? The weight attribute, here it is 0. The default weight is 0. Here you have set it as 200. So it will go via this way. You got it? So only when there is a tie in this, it will come to local preference. Only when there is a tie in local preference, it will come to local origin. What is local origin? If the same network is directly connected here on loopback, and you're advertising in BGP, which one it will prefer, local or remote? Local only. Local origin. But understand, the local origin also, it will come only after checking these 3. Okay. So next is shortest AS path. And it goes like that. So what I'm trying to